Type 2 diabetes is the most common type of diabetes. It is characterized by both inadequate insulin secretion and insulin resistance. In diabetes type 2, both genetic and environmental factors play a role. More than 60 genes have been identified that are associated with diabetes type 2. Environmental influences, in addition to genetic abnormalities, result in the mechanisms for diabetes type 2, which are decreased insulin secretion and insulin resistance. Multiple organs contribute to insulin resistance and chronic hyperglycemia. Obesity results in increased amounts of leptin and decreased amounts of adiponectin, which are hormones produced by the adipose tissue. These cause inflammation and decreased insulin sensitivity. Elevated levels of free fatty acids and intracellular deposits of triglycerides and cholesterol interfere with intracellular insulin signaling and decrease tissue response to insulin. Inflammatory cytokines released from the intra-abdominal adipocytes induce insulin resistance and are cytotoxic to the beta cells. Also, obesity is correlated with hyperinsulinemia and decreased insulin receptor density. In the GI tract, there is decreased levels of circulating ghrelin. Ghrelin is a peptide produced in the stomach and the pancreatic islets that regulates food intake, energy balance, and hormonal secretion. The decreased levels have been associated with insulin resistance and increased fasting insulin levels. These factors play a role in insulin resistance, which leads to an increased demand for insulin synthesis. As well as playing a role in insulin resistance, some of these factors also play a role in decreasing function of the beta cells. Beta cell dysfunction develops, which leads to a deficiency in insulin activity. This is caused by a decrease in the beta cell mass, as well as a reduction in the normal beta cell function.